Here's a cool difference of squares question that I want you to take a look at. Notice, and remember, when you're doing difference of squares, one of the things you have to remember is you look at the first one. Is that square rootable? Yes, 16x to the 4 is square rootable. That is going to give you 4x squared. Okay, so that means you put your 4x squared and your 4x squared here. But then ask yourself, is 81 square rootable? Well, yes, it is, to 9 and 9. Then ask yourself this, is this a difference? Yes, it is. So that makes this a minus, this is a plus. Remember, all those conditions must apply. Are they square rootable? Is it a difference? Then it is a difference of squares. But sometimes, some people don't see it. Some people will look at this question and say, oh yeah, we're done. Well, guess what? You're not. The reason why is because look at the definition. Are they square rootable and is it a difference? Well, look at this one. Is 4x squared square rootable? Well, in fact, it is. It's 2x. Is 9 square rootable? Yes, it is. It's a 3. But there's your problem. That's a positive. Can't do the difference of squares. So look at the first one. This one is square rootable. This is square rootable, and it is a difference. Oh my goodness. Okay, so let's square root this. We're not finished factoring yet. So the square root of 4x squared is 2x. The square root of 9 is 3. Make one a plus, one a minus, and you're good. But what about this other factor? Well, guess what? You just can't touch it. It doesn't work, so you just leave it there. It's done. So one of the things that you have to look for, what are some telltale signs that you're going to do multiple factorizations? Well, one of the big thing is look for the x to the 4. That's your telltale sign right there that something's up. You might have to do multiple factorizations. And then look for the pattern like we found here, with that being a difference of squares again. So here's the big note, what you got to do. Just because you factored once does not mean the solution is completely factored. Keep your eyes open. Look for things like difference of squares. So when we get to this next question, it's really quite interesting. Look at this. Again, remember, I told you, look for the x to the 4. There's your telltale sign telling you you're going to do more factorizations. Well, look at this. Can't GCF it, can't difference of squares it, so it's got to be a PSA 1. Okay, so here's our PSA 1 with 36 here and minus 13 here. And that's negative 9 and negative 4. Add those together, yep, of course, that's going to give you your negative 13. So your answer is negative 9 and negative 4. But don't forget, when you're square rooting x to the 4, that in fact becomes x squared. Okay, and your two other factors are minus 9 and minus 4. And lo and behold, exactly what I was telling you earlier. Oh my goodness, how pretty is this? There's a difference of squares. And guess what? That's a difference of squares as well, right? So difference of squares, this guy, which you know the procedure already. There's an x, there's an x, there's a 3, there's a 3. Make one a plus, one a minus, you're good to go. And the same thing goes for this one here, right? There's an x, there's an x, there's a 2, there's a 2, make one a plus, one a minus, you're good to go. Okay, so that's a really, really cool question that breaks down to 4 factors. Oh my goodness. All right, so let's keep on going. Let's look at this guy right here. Last question, all right? Again, can you GCF anything from this? No. But look, lo and behold, look at that. There's the x to the 4. So the power of this particular equation is 4, or what we call the degree of this equation is 4. And so when you see a degree of 4, that tells you, look out, there must be something important about this, okay? You might have to PSA twice, or you might have to do a PSA and a difference of squares. Some kind of combination might have to come into play here. So let's do it. We know that this is a PSA 1 already. How do we know? There's a 1 up front. That's usually your telltale sign, and the fact that this is a trinomial. So there's a 4, there's a minus 5, and look at that. Minus 4 times minus 1 works, minus 4 plus minus 1 works, so your answer is minus 4 and minus 1. So taking this guy over here, we have an x, oops, I don't need a bracket, I'm going to get rid of that. We have an x to the 4 minus 5x squared plus 4, which breaks down, there's where our bracket comes in, to x squared minus 4 and x squared minus 1. Now, a lot of people see this one and go, oh, look at that. There's your difference of squares. And so they go right into the routine of going x minus 2, x plus 2, right? But a lot of people don't see this. And remember what the difference of squares definition was. Is this square rootable? Yes, it is. Is this square rootable? Well, wait a second. Can you square root 1? Of course you can. The square root of 1 is 1. And is it a difference? Yes. So it checks out on all three. So this, in fact, can be square rooted in a difference of squares situation. This becomes an x, this becomes an x, this is a 1, this is a 1. There's your make your 1 plus, make your other minus, and you're good to go. Also notice that it doesn't matter which one's positive, which one's negative, as long as there's one representative of each. What a great set of questions that make you think one extra step.